Okay, so let's try this problem. So the figure shows the landing gear of a light airplane. So determine the compressive stress in strat AB caused by landing reaction R equals to 40 kilonewton. Neglect the weights of the member. The strut is a hollow tube with 50 millimeter outer diameter and 40 millimeter inner diameter. Okay. So, ayan, kung mapapansin nyo, no, para lang siyang, ano eh, tawag dito, para lang siyang laging statics ba? Okay? So, kunin muna natin yung pinaka free body diagram, ano. So, itong strut, so tatanggalin natin yan and we will replace that by a certain force. Okay? So, gawan ko muna dito ng free body diagram nang makita natin. Okay? And then, tingnan ko kung mabubura. Ayun, nabubura naman. Okay, ayan. Para, ayan. Okay? Yan. So, tatanggalin ko yung mga struts and other unnecessary na mga if meron akong reaction dito and then ito hinahanap ko, no. So, that is the force on the strut AB. Okay? So, para makuha natin yung force. However, this one, ang ating reaction daw dito is around 40 kilo Newton. Okay? And then of course, dito, meron ka ring reaction doon. So you have here CV and then you have here CH. Although hindi na siya mahalaga kasi I could take the moment on C, no? So I will have it summation moment at C equal to 0 for equilibrium and it should be clockwise positive. Okay? So we will be having here, ayan, naka mm naman siya. So 40 kilonewton multiply natin by 400 by plus 600. So that's 1,000 mm. And then minus ang kailangan nating internal force AB and then multiply natin by 600 mm. Okay? And then you have here 0 and then you will be having AB. So that's 40 times 1,000 all over 600. So that's around 66.67 kilo Newton. Okay? So, that's 66,666.67 Newton. Ayan, okay? So, para, ano. Now, since this is in, tawag dito, hollow. Okay? So, meron kang bilog. Bilog. And then, meron ka ring internal, no? So, ang kailangan lang nating makuhang area is yung area ng hollow tube. Okay? So, you have there, this one. Okay. So, meron akong outer diameter. So, you have here the D. And then, meron ka ring inner diameter. And then, let's call that as D. Okay? So, yung area natin, so that's pi all over 4 multiplied by D to the 4th minus D to the 4th. Okay? So, substituting. So, ang hinahanap naman natin is, ano ba? Determine the compressive stress. Okay, so we will be having here force P all over the area. Meron na tayong P that is 66,666.67 Newton. Okay, divide natin by area, pi all over 4. Okay, so we have here 50 squared minus 40 squared. So the maximum stress is 66,666.67 divided by pi all over 4, 50 squared minus 40 squared. And then the answer is around 94.31 MPa. So this is now the answer for this problem. Okay, so you need just parang statics lang, ano. So statics lang yan. Okay. So sige, copy and then I'll post another problem. Siguro ito. Okay. So we'll have this problem. Okay. Okay. So let's have this one. So the 100 kilogram uniform bar AB is suspended from two cables AC and AD, each with cross-sectional area of 400 millimeters square. Find the magnitude P and the location X of the largest additional vertical force that can be applied to the bar. The stress in AC and BD is 100. O, so lagyan na natin ano? Dito is 100 megapascal. Dito in BD is just around 50 megapascal. Okay? So, pwede natin yang i-maximize na dalawa, no? Kasi, kung mapapansin nyo, dalawa yung unknowns. So, kung dalawa yung unknowns natin, P and X, ibig sabihin, dalawa din yung equations na pwede nating pagkuhanan. And that is actually the stress on the member AC and then the stress on the member BD. It means, pwede natin ma-utilize yung dalawa. Okay? Paano yun? Ito, kunin muna natin yung tawagin natin tong tension at AC. So, I will call that as TAC. And I will call this one as my TBD. Okay? So, TAC, it's just equal to the stress multiplied it by the area. So, stress times the area, or that's equal to 100 megapascal. And then the area, parehas naman daw sila, each 400. So, you have here the TAC is equal to 100 times 400. So, that's 40,000 Newton. Okay. Gawin na nating kilonewton, ha. Newton is equals to 40 kilonewton. Same thing yung gagawin ko sa BD. So, that's around 50 multiplied it by 400. Okay? So, gawin ko ng in kilonewton. Paki-divide na by 1,000. 50 times 400 divided by 1,000. So, you have here 20 kilonewton. Okay? So, ito pala, that is 40. And then this one is, that is, ilan to? 20, no? Okay. Meron din ako ditong weight ng bar. Okay? So, yung weight ng bar ko, okay? So, I have here 100 kilograms multiplied it by 9.81. Divide ko na by 100, by 1,000 para maging kilonewton. So, that's 1,000. So, 9.81 kilonewton. Okay, with this, pwede akong mag-summation forces vertical, no? So, I could take it summation forces vertical equal to 0. So, I have here TAC, okay, minus P minus W plus TBD. No other forces equal to 0. So, I will have TAC as 40 minus P minus 9.81 plus 20 equal to 0. So, you can now have the value of P. So, that is 40 minus 9.81 plus 20, and that's around 50.19 kilonewton. Okay, so ito yung magnitude ng force P. How about the location? Pwede ako mag-moment at any point, no? So, I could take a moment about A equal to 0. Clockwise is positive. So, I have here 40. Wala na pala akong 40 kasi tumatama doon. Pero, pwede kong gawin, I have here Px. Okay? Plus W multiplied it by 1 meter. and then minus TBD multiplied it by 2 meters equal to 0, no? So, ang PX ko, so that is 50.19 of X plus W, which is 9.81 times 1 minus TBD is 20 multiplied it by 2, and that's equal to 0. So, the only unknown is X. So, that is 20 times 2 minus 9.81 divided by 50.19. So, you have here 0.602 meters. So, this is the maximum and the location of X para hindi masira yung ating mga cables. Okay, so that's it. So, you have here 602 millimeters. So, that's the answer for these problems.